Okay, so I think we can start now. Almost everyone has joined. उसको प्लस लगाना होगा तो नहीं है इसमें नहीं है बोल प्लस नहीं ऐसा कुछ Okay, so very welcome you all to the physics class. This is your first physics class of the session. Okay, and today you have I think this is your first class or second class.
First class, sir.
First
Okay.
class, sir.
First class, very good. See, physics is a part of science. Okay, and what part of science we talk of in physics? In physics, we talk of nature and natural phenomena. That means we talk of the phenomena which are relating to nature. So every day we observe certain phenomena relating to charges, and we try to explain those concepts. So not only charges, there are various other concepts which we see every day around us, and we try to provide a explanation to those things. So this we call as nature and natural phenomena. So that is, so in physics, we'll be studying the natures and natural phenomena. For example, I will tell you some of the things which you will try to explain that yes, it happens or not. So I think most of you must have tried about balloons, inflate balloons, rub with your hair and try to stick them on the wall. So have you tried to stick balloons? So balloons rubbed with hair stick to the walls. Who all have observed this phenomena? Okay, anyone has observed this phenomena? Anyone has done this activity? Okay, if you have not done, I will tell you one activity similar to this, which you can do right now. So if you have a plastic scale with you, so I think everyone must have a plastic scale with him.
Yes, sir.
Yeah. So take some small bits of paper, very tiny bits of paper, okay, and rub the scale with your hair. Rub the scale with your hair for around just 3-4 times and bring that scale near those bits of paper. Bring your scale near those bits of paper. Plastic scale. Okay, so what do you observe? Do you observe anything?
The paper will fly with the scale.
Yeah, the paper flies and jumps to the scale. It sticks to the scale. Okay, so we observe that the bits of paper. So here we observe that bits of paper stick to the bits of paper, stick to the scale. So everyone has observed this. In the same way, we can see about the balloon also. With the balloon also, it happens the same thing. Another phenomena you have observed a number of times, like in winter, if you take off your clothes. So while taking your clothes, you might have observed some sparks coming out, or you might have heard some chit sound coming from your uniform. Have you observed those things?
Yes, sir.
Yeah. So the reason behind all of them is charges. There is a transfer of charge which takes place from one object to the other, making the objects charged, charging the objects. And hence, charging involves some forces of attraction and repulsion. So we have that there are two types of charges. There are two types of charges. They are the positive charges and the negative charges. Right. Let's see. The charges are denoted by the sign plus and minus. It's just that there are two types, and their types are denoted by just plus and minus. Okay. So the two charges, there are two types of charges which we call as positive charges and negative charges. Okay. Now the two types of charges, they attract each other. If the two types of charges, they are opposite to each other. If the charges are opposite to each other, then they attract each other. And if they are similar to each other, then they repel each other. So we know that the similar charges repel each other and opposite charges attract each other. So we will do one more activity to understand what's happening. Okay, so that activity you can try out later. I will just explain you what happens in the activity. If you are able to do that at your home, since you are free for the whole day, I think. Have your school started?
No,
No?
sir, not yet.
No, sir.
We have
Yeah.
holidays.
Started,
Yeah.
sir.
So okay, so still if you have time, you can see, you can try doing this activity. This is also a very interesting activity to understand about the nature of the charge. Okay. So for this, we take a bottle or a glass jar. So we take a bottle or a glass jar and see. So in this bottle or glass jar, so in this bottle, we put a metal wire. Okay. So first of all, we construct a metal wire passing through this bottle, and this metal wire should be tied to another metal wire, something like this. The two metal wires should be attached like this, and after we insert them, we can put a stopcock. So here we can seal it with the stopcock. We can provide a stopcock over here. Now you need to hang two blades. You need to hang one blade over here and another blade over here. So you need to hang two blades. Why we use blades is that blades are good conductors of electricity. Yeah. So see, you have these two blades, they are hanging from here. The blades are good conductors of electricity. Okay. Now, the way you rub your scale. So again, if you rub your scale and place that scale on this point of the wire. So if you place the scale at this point of contact of the wire, we will observe that these two blades, they repel each other. So these two blades, they will repel each other, and hence these two blades will become something like this. You will observe these two blades to be hanging like this, repelling with each other and becoming like this. So they will repel with each other and become something like this. Okay. So why it happens? Yes, and Lasya,
Yes, sir. So the orange shaded part is the uh, closer, sir, which will close the bottle.
what happened? Just pardon.
The orange is the closure of the bottle cap,
Yeah,
sorry.
it's the closure of the bottle, but it should not be made up of metal. The only thing is that it should not be made up of metal. It can be plastic.
Okay, sir. Thank you,
It
sir.
should not be a metal, as metals are good conductors of electricity, so we should not use metal over there. You can make it something like this. You can take a plastic bottle, make a hole through that, through its cap, and first make this arrangement, then put this arrangement inside this bottle and turn on the knob. Okay, so this will work. Now you will observe that these two blades, they move away from each other. Okay,
Okay,
so
sir.
we have been taught in our earlier classes that similar charges repel each other, right? We know that the similar charges repel each other. So that is what is happening over here. When you bring the scale in contact with this surface, if you bring the scale in contact with this surface, so here what happens? When the scale is in contact with the surface, then what happens? Then all the charges which were accumulated on the scale while we rubbed it on our hair, the charges were transferred from our hair to the scale. Okay. And when we place the scale on this contact, those charges, they travel through this metal wire, pass through both of the blades. So both the blade, they acquire similar type of charges. Okay. Since both the blades, they acquire similar type of charges, so they repel each other. Okay. They repel each other. So here we observe that charges are similar. So they repel each other. Whereas we observed one thing, that when you bring the scale towards those bits of paper, it attracts them. So that means charges can either attract or they can repel, right? So if the charges are placed together, they will either attract each other or they will repel each other. If the charges are similar, then they will repel each other. And if the charges are different, then they will attract each other. So you can write a note here that we can put a note that similar charges, repel each other, and opposite charges, attract each other.
Sir, the negative charges
Yes.
will pass from the scale to the vertical wire and then go to the horizontal wire, sir.
Yeah. And after the horizontal wire, they will go to the blades,
Yes, sir. Then negative and negative charges will repel each other.
repel each other. Okay. Now another phenomena I'll tell you similar to this. I hope you might have observed it. So if suppose you have a plastic chair, okay, you rub that plastic chair with a silk cloth. Rub that plastic chair with a silk cloth. So again, similar thing will happen. charges will be transferred from the plastic to the silk cloth, and if you touch that chair, you will get a shock. Or if you bring your hands closer to it, you will find the hair of your body, they become erect. A similar thing you have observed with your LCD or your TV. With your TV, if you bring your hands near your TV, you will observe the hair on your hands. They become erect, they become straight, right? So all these effects, they are brought about by the charges. Okay. So how many types of charges are there?
Positive charges and negative charges.
Two charges.
Yeah,
But there
very
are
good.
two types of charges.
There are two charges.
Yeah, there are two types of charges. They are the positive charges and the negative charges. Okay. So now which charges will be called as the positive charges? Which charges will be called as the negative charges? To understand that, we understand a little bit about the structure of atom. Okay. So we need to get into the structure of atom to understand the charges. Okay. So let's see the structure of atom also. So how many of you know about the structure of atom? Anything?
Sir, I know, sir.
Yes. What do you know?
Sir, an atom is the smallest particle of an object, and it contains electrons and protons. So electrons revolve around the orbit of the nucleus, and protons and neutrons will be in the nucleus, sir. The nucleus will be present in the center of the atom.
Okay. So a very good explanation by Pranava. A very good explanation by Pranava. Who else
Thank
can explain about the atom? Can anyone explain about the atom?
Sir, atoms have a system uh, where it revolves around the air,
Hmm.
and there are many atoms that we can see by our naked eye, and they are
Hmm.
and the system in the atoms there is a system even which will be revolving inside the atoms.
Okay. See, when we are talking of atom, a very simple way to understand atom is whatever object you have in front of you. You may have your table, you may have your chair, anything, any object you have, you try to break it. Okay, you try to break it. So you will be obtaining very small particles of it. You can break and obtain small, it can be broken into small particles. Okay. Now, you can try to burn it. By burning it, you will be able to turn it into even small particles. Okay. So, why we when we say atom, atom is the smallest particle which cannot be broken down. You cannot break it further. So, the particle which cannot be broken down further, we call it as the atom. So, all the things that we see around us, all those objects, they are made up of atom. Okay. All the objects around us, they are made up of atoms. Okay. So next one, here I present a simple idea of the atom, how an atom would look like. So atom, see, atom is invisible with the eye. You cannot observe a single atom. It's so small that you cannot observe a single atom. Here in the center, we observe a here in the center, we observe a nucleus of the atom. So we are observing here a nucleus of the atom, and this nucleus of the atom, it is holding certain protons and neutrons in it. Okay. So this atom is holding some protons and neutrons inside it, and surrounding it, there are certain electrons which are revolving. So you have some electrons revolving around this. So this is one orbit. You can have a number of orbits. A number of orbits are possible. So just like this, there will be another orbit. in which electrons will be revolving. You get another orbit. Now the electrons will be revolving in these orbits. So see, you have the first orbit, the second orbit, and in this way the electrons are revolving in orbit. Now we are calling these electrons. So these particles, they are electrons. And in the center, you have protons and neutrons. So this is your nucleus, which consists of protons and neutrons. Okay. So the electrons carry a positive charge. Electrons carry negative charge, and they are very light, whereas the protons carry positive charge. The neutrons, they do not carry any charge. They are neutral. They do not carry any charge. Okay. Now, overall, the atom is neutral. So, overall, whatever particles are around you, they are neutral. Overall, the atom is neutral. Okay. Now, how we come to know about the charging? It is when we rub the scale with our hair, the electrons are transferred. From the atom, the electrons are transferred onto the scale. Okay. So here it is the transfer of electrons which makes it charged. So suppose you have the scale and you rub the scale with your hair. Suppose there are 10 electrons which are transferred to it. So you have 10 electrons being transferred to the scale. Now it is because of this that the scale will become negatively charged. Okay. So by the transfer of electrons, here we observe transfer of electrons. So it is due to the transfer of electrons that the scale becomes negatively charged. Okay. And hence it starts attracting those bits of paper. Got it?
Yes, sir.
Okay. So the negative charges, they are represented by either this E symbol. Okay. So this is negative charge or electron. Now we observe a number of things around us. We observe our electrical appliances, we observe electrical circuits, we observe cells. So we will try to understand those particles. What are those cells? How do they work? Okay. How does the transfer of energy take place? Okay.
Sir,
So
the
let
outermost shell of the atom is called valence shell.
yeah, the electrons in the outermost shell are called as valence electrons. So as there are a number of electrons, the electrons in the outermost shell, they are called as valence electrons. Whereas the electrons in the inner orbitals, they are called as inner orbit electrons or inner electrons. Now, for this, I hope everyone has understood. So whenever I call a charge, okay, so each electron carries a very small amount of charge. We'll see how much charge is there on an electron. Okay. So charge on an electron. An electron has a charge of 1.6 charge on electron. So we write it 1 electron charge. is equal to 1.6 multiply 10 to the power minus 19 Coulomb. C. The C symbol means Coulomb. Coulomb is the SI unit of charge. So what is the SI unit of charge?
Coulomb.
Yeah, Coulomb. So Coulomb is the SI unit of charge, generally represented by capital C. Coulomb is the SI unit of charge. Now we understood that how the charge on an electron is represented. This is a very small amount of charge. A very small amount of charge is there on an electron. Okay. The same charge is there on a proton also. So a proton also has the same charge. A proton has charge of 1.6 multiply 10 to the power minus 19 Coulomb. Only thing, the charge on the electron is negative, whereas charge on the proton is positive. Now, we will see a simple circuit. How does a bulb glow? So let's try to visualize that how a bulb glows. So here, there are different circuit elements. You have a bulb and we put here a switch. So we put a switch. Okay, this is a switch. And I'm putting here a battery or a cell. So this is the symbol I'm drawing for a battery. You can see the symbol for a battery consists of vertical lines. Okay. So here, two vertical lines will be there, a bigger one and a smaller one. This represents a cell. So this symbol represents a cell where the bigger line will represent a positive terminal and the shorter line will represent a negative terminal. Okay. So in reality, if we observe the cells, how do we see the cells? Whenever we see a cell, we see a cylindrical object like this. We observe a cylindrical object like this. Okay. You have the two terminals. This terminal will be the positive terminal and the bottom terminal will be the negative terminal. Right? So the same thing, the same cell can be drawn with this symbol. Okay. If you use a battery, so you can use a combination of these. Okay. A battery will be drawn like this. A battery will consist of more set of these cells. It will be a combination of cells. So you have a cell, another cell, and the two cells being combined to each other will form a battery. So two or more cells joined with each other form a battery. We see here that these are the two cells which are joined together. If we try to join them physically, so physically they are joined something like this. To join these cells physically, we will be joining something like this. Okay. So you can join two cells like this. So positive of the one connected to the negative of the other. This is how they should be joined to form a battery. So this is a battery where you have positive, negative, positive, negative. So the same has been drawn with the help of symbol. If you draw it with the help of symbol, it will be like this. So this is a symbol of battery. Okay. Now what happens when we use a battery or a cell? So when we are using a battery or a cell, see, the electrons from the negative terminal of the cell, so the electrons which were present at the negative terminal of the cell, those electrons, they travel through the wire. So through the wire, those electrons, they travel from the negative terminal of the battery towards the positive terminal through the wire. Okay. So when they travel through the wire, they will cause the electric bulb to glow. So how does a bulb glow? Can anyone explain? How does a bulb glow when connected to a cell or a battery?
Ma'am, sir, the negative charge from the battery will pass through the wire and goes to the bulb, which causes it to glow.
Yes, the negative charges from the negative terminal of the battery, they pass through the wire, pass through the bulb, and reach the positive terminal of the battery. Okay. So
So
therefore, the bulb will,
the wire goes through the filament of the bulb, right, sir?
the wire, of course, the filament of the bulb is connected to the two wires.
Yes, sir.
Okay. So if the filament breaks, then the bulb will not glow.
Yes, sir.
So of course, we can say that filament of the bulb is connected to the wire. Yes. So everyone has understood how the bulb glows. Now here scientists left something a little bit of confusion for the kids. And the confusion is that they said that electrons are moving from negative terminal to the positive terminal, but they defined current and they said that current means current we will also always take to be positive. And they told that we will be making the direction of current from the positive terminal towards the negative terminal. So the direction of current is taken from positive to negative. In reality, it is the electrons which are moving from negative to positive, but we take the direction of current from positive to negative, that we also call as the conventional current. Okay. So conventional current is taken from positive to negative. Okay. So I hope all of you enjoyed today's class. Anyone has any doubt?
Sir, can you explain conventional current once again?
Conventional current, see, current means anything which is running, which is moving. Okay. So this movement of charges is also called as current. Okay. So conventionally we consider only the positive charges. So that is why the scientists still they consider the movement of charges to be the positive charges. In reality, it is actually the electrons which are moving. But we consider the charges to be moving from positive to negative. And hence we take the direction of current to be from positive to negative. So that is the direction of current that will be taken. Current is represented by the symbol I. Its SI unit is ampere. So what is the SI unit of current?
Ampere.
Ampere. So in the
SI unit
next
of
class,
charge is coulomb and current is ampere.
ampere. Okay. So this I'll be adding, everything will be available in the resources section to you. You can refer it later on also. Okay. So bye everyone. We'll see you again tomorrow.
Sir, we will get the notes, sir.
Yeah, these notes will be available in the resource section on the WISE app.
Okay, sir.
Okay, bye.
Thank you, sir.